Hello.
Hello, can you hear me?
Yeah. So
Okay.
let's discuss all the problems that you have from this chapter 1 questions.
Okay. I tried most of them
Hmm.
and I cannot do 1.4344
Let's
for
list them down 1 second. 1.43.
44
Hmm.
45
Okay.
and the IMO questions I haven't tried. So basically the last three I haven't tried.
Okay, fine. Okay, so let's see what this is about. 1.43, right?
Yeah.
Okay. JMO 2011. Points A, B, C, D, E lie on a circle W and point P. I'll write it. A, B, C, D, E, D, E are on a circle W and point P is outside. P is outside. Okay. Given points are such that PP and PD are tangent to W and PAC is collinear. PAC collinear and we have DE parallel to AC. DE parallel to AC. You have to prove that DE bisects AC. Okay, so A, B, C, D, E are on the circle. P is outside. PB and PD are tangents. Fine. Let's try to draw a rough figure. So we should put point P somewhere here. P. Let's say B is here. And let's say D is here. We have PP and PD as tangents. Right?
Yeah.
And A, B, C, D, E will be arranged on this A, B, C, D, E. Okay. So such that P, A, C are collinear. So P and C should be maybe here, and then
Yeah.
A should be here. So that there is a straight line from them.
Yeah.
Okay. And E, D, E is parallel to AC. Okay. So E should be like this only somewhere here. Right?
Yeah.
These two lines are parallel. These lines are parallel. Okay. This is C. This is P. We have to prove that DE bisects AC.
Yeah.
So we have to prove that this is equal to this.
Yeah.
And okay, uh, let's think about it.
So my thought is to prove a perpendicular from the center.
Prove a perpendicular from the center.
Yeah.
So let's say O is the center, right?
Yeah.
And midpoint of AC should be M, some midpoint, and that will be perpendicular, right?
Yeah.
So we have to show that that midpoint is same as this point, right?
Yeah.
We have to show that those 2 points are identical.
Yeah.
Okay. Fine. Okay, so let's call this point as M. This is a random M is point of intersection of DE and AC, Right now, we don't know whether it is midpoint or not, right?
Yeah.
If we can show that OM is perpendicular to AC, then we are done, right?
Yeah.
Let's join this. If we can show that this angle is 90, if OM perpendicular to AC, we are done, right?
Yeah.
So, okay, so it's about finding this angle now, or showing that this angle is 90. Okay, so let's think about how we can try to do that. Um, okay, we have PAC is collinear. This is one line. These are tangents. These are tangents from here. So we know for sure that these angles are 90. PBO
Oh,
and
yeah.
PDO, right?
Yeah.
Okay. PBO is equal to PDO. That also we know. And so I'll just write that angle PBO is equal to PDO is equal to 90 degrees, right?
Yeah.
Uh, Fine. Then uh, let's think about what else we can say. We join this. So if we join this, we have alternate segment theorem, right? So basically, when there is a tangent and there is a chord, this angle should be equal to this angle, right?
Yeah.
That we know from basic geometry. So this is a chord, PV is a tangent, right?
Yeah.
And this angle must be equal to this angle, which is basically PBD. Hmm. Wait. Uh, Actually, since this is an isosceles triangle, because tangents are of equal length, we can say this angle is also same, right?
Yeah.
Because from an external point, tangents will be of equal length. So if PB is equal to PD, so this angle is equal to this angle is equal to this angle, right?
Yeah.
Okay. And now what we can say, uh, let's join this also. This is O to D, right?
Yeah.
So O to D we know is 90, and this is, let's say, theta. Then this is 90 minus theta, right?
Yeah.
90 minus theta, and this is theta. And uh, can we find out this angle?
Oh, yeah. There's a parallel. So this is
Oh, yeah, yeah, yeah. It is parallel, thank God. Yeah, so it's parallel, so this angle is equal to this angle, so this is also theta, right?
yeah.
Theta, correct. So now, if you see, you have in the quadrilateral, actually it is a pentagon, right? So what can we see? Can we do some cyclic quadrilateral stuff is what I'm thinking. Uh, can you just, if you just focus on quadrilateral PDMB, right?
Yeah.
Right now, forget about the O here, right?
Yeah.
PDMB, we can say that, uh, is it cyclic? Yes, it is cyclic because BP is a chord and BP is subtending theta here and theta here, right?
Yeah. Yeah. Oh, yeah.
Right. BP chord is subtending same angles, theta here and theta here. So it is cyclic, right?
Also, the 5 points are all cyclic.
We know PDMB is cyclic for sure. Now, can we
Oh,
show that O is also on the circle?
oh, because there are two 90 degrees,
Uh,
ODP and OBP.
ODPB, yeah. ODPB, there are 290
Yeah.
degrees. So cyclic. So basically 5 points are cyclic, right?
Yeah.
So O is also on the same circle, right?
Yeah.
So if it is cyclic, now we know that uh, this is 90, right?
Which one? Oh,
O,
yeah. OB.
OB and P, right?
Yeah.
Uh, can we show OM is perpendicular to PC from here? Is what I'm wondering. OM is perpendicular to basically the APC line. So if by cyclic we can show that, then we are done. We just need to show that.
By OMBP, right?
OMPB.
B.
Oh yeah, OMPB also
Oh,
all
yeah,
are
yeah.
cyclic. By OMPB, we know that uh,
So OMP is equal to OBP.
angle OMP is equal to angle OPB, correct?
Yeah.
OMP is equal to angle OPB because basically PDMBO are all cyclic, right? So this means it is equal to 90 degree because this angle is 90, right?
Yeah, I think I missed the OMBP cyclic part, so I couldn't do it.
Yeah. So basically it's about drawing the figure and remembering that because of this parallel line, it becomes cyclic, right?
Yeah.
Because first thing that we got PDMB is cyclic we got. After that, we can show that all of the things are cyclic. Three other quadrilaterals, right?
Yeah.
So yeah. So once we have done that, we know that OM is perpendicular to AC, and that means BE bisects AC, right?
Yeah.
Okay. Let's go to 1.44. Okay. Uh, this one says that there is an acute triangle ABC. Acute triangle ABC. Let DE and CF be altitudes. Okay, fine. I'll draw the figure. ABC be in acute triangle. DE and CF are altitudes. A, B, C. Acute triangle BE and CF. Altitudes. and denote by M the midpoint of BC. Midpoint of BC is here M, which is this and this. Okay. Prove that ME, MF, and the line through A parallel to BC. There is a line through A parallel to BC. It should be like this. ME is like this. MF is like this. ME, MF are all tangents to the circumcircle of AEF. Okay. So we have to show that ME, MF, and line through A parallel to BC are all tangent to circumcircle of AEF. Okay, so we can draw a rough triangle here and this triangle circumcircle, right?
Yeah.
We have to show that this is tangent like this. This is also tangent like this, and ultimately it is tangent like this.
Yeah.
Okay, so fine. Okay, so the intersection points of BE and CF is called H, which is orthocenter, right?
Yeah.
Orthocenter of the triangle. So angle HAE, we can draw a line like this, which will be altitude here, right?
Yeah.
So HAE, this angle is equal to 90 minus C, obviously.
Can we show that this point also lie on the circle?
So hopefully that will come. Like maybe that will come out, right? Right now I'm just seeing the angles. So maybe it will come out on its own. 90 minus angle C, and if you notice this angle, what is this angle? See, this angle, because ME line, is ME line parallel to this?
No.
Not necessary, right?
Yeah. But
Uh,
like from the graph on the book.
it is not, right?
Yeah.
So okay. HAE. Okay, how else can we prove tangents? We could use alternate segment theorem and try to do angle chasing.
I feel that maybe the H lies on the circle is helpful. Can we show that?
What?
The
H lies on the circle.
Yeah.
Uh,
I'm not sure.
if we can, okay. It feels like it should lie on the circle, right?
Yeah.
Looks like it lies on the circle. So maybe we should try that. So in order to show that, we will have to show that this angle is maybe equal to this angle, right?
Yeah.
So this is the line joining the foot of the altitudes, right?
Yeah.
And let's call this D, right?
Yeah.
Now, what we can, if we join this and this also, right? This gives us the orthic triangle or pedal triangle, right?
Yeah.
And we know, I mean, I know, and we can prove easily that any altitude is an angle bisector, right? In the orthic triangle.
Yeah.
You know this, right? Any altitude.
I think we discussed in the last lesson.
Yeah, yeah. So, so, so what you can show is that the angles of the orthic triangle are basically 180 minus 2a, 180 minus 2b, and so on, right?
Like in which triangle, DEF or ABC?
Huh. So this depends on basically this angle would be 180 minus 2a because it's opposite to angle A. And the altitude will bisect it. So this much would be 90 minus A, this much would be 90 minus A, right?
Is it? I'm confused.
Okay, so the orthic triangle stuff we can easily do. There is no issue there. So uh, let's say this is a regular triangle. I have made three altitudes, right?
Yeah.
And I join them. Okay. So this is one orthocenter, and these are D, E, F, and C, A, and B. Now you can show you can obviously see that HEDC is cyclic, right?
Yeah.
HEDC is cyclic. That means this chord will subtend same. This angle will be same as this angle, right?
Yeah.
And this angle is clearly 90 minus A.
Oh, yeah.
So this is also 90 minus A.
Oh, yeah.
This half of it, right?
Oh, yeah.
And
So the other one, yeah.
here also is a cyclic quadrilateral. So this angle will be equal to this angle. This is 90 minus A also, right?
Yeah.
So that is why I'm saying it is 90 minus A, 90 minus A here.
Okay.
And the altitude is the angle bisector, basically, right?
Yeah.
Right. So
Yeah.
by that theory only, we can say that this altitude will be angle bisector of the triangle here, right?
Yeah.
And that means since altitude is angle bisector, this angle must be 90 minus C, right?
Yeah.
So that means we have proved cyclic, right?
Yeah.
You understand no, why it is 90 minus C?
Yeah.
Because this is an altitude again, right?
Yeah.
And this must be angle bisector. So now we have 90 minus C here, 90 minus C here, which is obvious. And therefore we have cyclic, AHFE.
Okay.
Okay. So if AHFE is cyclic, can that help us? Like we have to prove that MF line is tangent to this circle, right?
Yeah.
So, okay. So also we know that AH is diameter, right, of this circle.
Yeah.
Why? Because this angle is 90, right?
Yeah.
Correct.
Yeah.
AH is diameter, this angle is 90, and MF line. So midpoint of AH is the center, right?
Yeah.
Correct.
Yeah.
Midpoint of AH is the center. How do we prove tangency? Okay. We can prove tangency by showing angle 90 degree with. You understand what I'm trying to say, right?
Yeah. Yeah.
Like there is a circle, I have to show that this line is tangent. So I have to show that the midpoint of this makes 90 degree. But maybe that will be
Yeah.
slightly annoying to do. Is there any other way to show tangency?
Yeah. I think I'm kind of getting it.
I know. We have a nice cyclic quadrilateral. Can we show tangency in some nice way?
Can we like denote if the center is O?
Okay, I'll make a slightly better fit over.
Yeah. So we simply need to show that OAF equals CFM.
Hmm.
Yeah.
So this is my one altitude, BE is my other altitude, and CF is my other altitude. This is H, this is E, this is F. There is a circle here. There is a circle here that passes through all of these points. And midpoint of this is O, let's say, right?
I think I get it.
And this is how?
Like, oh, because like M is a midpoint, so
Uh,
FM equals MC.
M is a midpoint of this, right? So
Yeah,
FM equals MC, right?
because it's a 90 degree, and this is a hypotenuse.
No, you are assuming it is 90 degree. We have to prove that it is 90.
No, CM, I mean, the CMB is 90 degree.
CM,
Oh no, CFB, sorry.
CF, which one? This is 90.
Yeah, and
CFA is 90, no?
CFB is also 90.
CF, what is P? Which
B,
one is
B, A, B, C, B.
CFB? Okay. CFB is 90.
Yeah, so FM equals MC.
So you're saying, oh, you're saying this is circumcenter.
Yeah,
Circumcenter of triangle BFC, right?
Yeah.
So FM equals MC, correct?
Oh, yeah.
Right? Because midpoint of the hypotenuse is the circumcenter, right?
Yeah, then MFC, angle MFC equals angle MCF.
MFC, yes, MFC is equal to angle MCF, and this angle we know is 90 minus B, right?
Oh, yeah, so that one is also 90 minus B.
So this one is 90 minus B, and
then we connect OF.
and then we connect OF, correct?
Or then we only need to show that AFO equals CFM. Is it?
So we need to show that whole thing is 90, and this is already 90 minus B. So we need to show that this angle is B, right?
Oh, yeah.
Show that this angle is B somehow, right?
Yeah.
So since
okay. So OAF is 90 minus B.
So OAF is 90 minus B, we need to show,
yeah.
Right? And that is easy, I think, because we just need to show that OAF is 90 minus B, and this is center, so we know this is equal to this, so this will also be 90 minus B, right?
Yeah.
So this will be 2B, right?
Yeah.
Because 180 minus B, so this will be 2B, and that means that we have to show that this angle is B, right?
Yeah.
Because this is angle at the center, and this is point, right, on the circumference. So can we show that this angle is B? We are joining F and E. Yes, I think we can show that because we have already shown that in a pedal triangle, this angle is 90 minus B, right?
Yeah.
Because again, by the previous logic, right?
Yeah.
So now we write all the steps in the backward order, right?
Yeah.
We say that this is 90 minus B, so this is B, this is B, and we know this is center, so these are equal. So this will be 2B and this will be 90 minus B, right?
Yeah.
And then we say this is B, and then we are done. You understand?
Yeah.
So basically the key idea was what? AFHE is cyclic, and then noticing that in this right angle triangle BFC, you can say that MF is equal to MC and the angle here and angle here, right?
Yeah.
After that, it's just simple angle chasing and some simple properties.
Yeah.
Okay.
How about the line through A parallel to BC?
Line through A parallel to BC. Again, because it is parallel, we'll know the angles, right? We'll know this angle is B. So this angle is B. Again, same angle stuff, right?
Oh, yeah. Also that AEF is also B.
Correct. You understand, right?
Yeah.
All the steps will be done by angle chasing. Once you have some small angle, you start by seeing what you have to prove slowly.
Yeah.
Right? You have to basically prove that for this to be tangent, you have to prove that OA this is 90, right?
Yeah.
So if this is B, you have to just show that this is 90 minus B, which is obvious, right?
Yeah.
You understand?
Yeah. I
Okay.
think I didn't show the ortho
Like,
center is on the circle, so I couldn't proceed.
so orthocenter is on the circle. How did we show? We showed it by angles only. I think you couldn't show that because the uh, in center, the fact that pedal triangle is bisected, right? That one.
Yeah.
This is equal, and this is 90 minus A, 90 minus A. That point you have to realize, right?
Yeah.
Once you know that, you can show it. It is cyclic easily.
Yeah.
This one. Okay. Uh, Fine. Which one is next one? 1.45.
Yeah.
Okay. Um, okay, figure is given. So let's draw the figure. A, B, C. In circle of ABC is tangent to this at 3 points D, E, F. Okay. I'll draw an in circle. Okay. This is called F. This is called D. This is called E. Okay, let M and N be midpoints of BC and AC respectively. M is midpoint of BC and N is midpoint of AC. N is here. And then what are we doing? Ray BI meets line EF at K. Ray BI. In center will be center of this circle, right?
Yeah.
And the ray BI, this is I, meets line EF at K, meets it outside here at K, right?
Yeah.
And we have to show that BK is perpendicular to CK, okay? B to K is perpendicular to CK, right?
Yeah.
Start this off. This will be N here. We have to show that this is 90, okay? Then show K lies on line MN. K lies on line MN. First BK perpendicular to CK, then MNK collinear, right?
Yeah.
Okay, uh, let's think about this. BK is perpendicular. Hmm. Hmm. M and N are midpoints. Maybe M and N will come in later. First, we have to show perpendicular. So first of all, like simple angles, we know this angle is B by 2, right?
Yeah.
And K and CK, okay. These are points of tangency. We know that AF and AE are equal in length, right?
Yeah.
And similarly for BF and BD and stuff, right?
Yeah.
So this is an isosceles triangle and this is angle A, right? So
Yeah.
this must be X and X. So this should be 90 minus A by 2, right?
Yeah.
90 minus A by 2, and this should also be 90 minus A by 2, which means this is 90 minus A by 2, right?
Yeah.
Okay. And now because we know this is B by 2, we know this angle also, right?
How?
Because B by 2 and this is how much? 90 plus A by 2,
Oh,
right?
yeah. Yeah.
Right.
Yeah.
And this is B by 2, 90 plus A by 2. So it is 90 plus A by 2 plus B by 2. So this should be C by 2, right?
Yeah.
This angle is C by 2 we have found out. We have found out this angle is 90 minus A by 2. This angle is the small angle. KEC is 90 minus A by 2, right?
Yeah.
This is C by 2. So, okay. What else? We know this angle also because C and D by 2, right? So to prove right angle triangle, I have to show that this overall angle is 90 minus B by 2, right?
Yeah.
This overall angle is 90 minus B by 2 somehow, right?
Yeah.
So I have to show that the small angle here, right, should be 90 minus B by 2 minus C, right?
Yeah. Wait,
Okay.
can we use that C by 2 and connect EIC?
Can we connect EIC? Okay, we can.
And get a cyclic.
Which one is cyclic you're saying? KEIC.
Yeah.
So we know that
Use a half C.
this also. Yeah. So we can say that now since we found that this is C by 2 and we know that this is C by 2, right?
Yeah.
So we know that KEIC is cyclic, right?
Yeah.
Because of the C by 2 matching, right?
Yeah.
And since we know that KEIC is cyclic, now I think our job should be easy because we know that this angle is 90, right? Right.
Yeah. Yeah.
So this is a diameter EC, right?
So this directly show that IKC is also 90.
So this directly shows that IKC is also 90 because obviously because this is diameter.
The same chord.
Right. Correct. So this shows that this is 90, right? You understand why, no? It's obvious. Same
Yeah.
chord IC, right?
Yeah. Oh, I didn't get the C by 2, so
Correct. So once you get C by 2 here, then you can show KEIC is cyclic. And if KEIC is cyclic, you get that IKC is equal to 90 degree, right?
Yeah.
C by 2, how did we get? We got it by saying that this is equal to this, right? And this angle we found once we found this angle, you look at this big triangle here, and then you find the angle here, right?
Yeah.
So we have proved the first part. Now we have the second part. We have to show that M and K are collinear. M and K are collinear. So this is a straight line. In order to prove collinearity, like it is good if you can say that this angle plus this angle is 180, right? That is one way you can show that the lines are collinear, right? Or you can
Yeah.
show vertically opposite angles are equal.
Yeah.
So whatever way you prefer, so let's see if you can find out this angle and this angle, that will also be okay. So
Okay.
uh,
Do we know angle BKM?
angle which one?
BKM.
BKN. So that is basically IKN, right?
Yeah.
So N is also a midpoint. So we should somewhere that has to be used, that these are midpoints, right?
Yeah.
Oh, we know that MN is parallel to the AB, right?
Yeah. I'm trying to see
Ah,
whether EKN
basically
is.
this angle is A, right?
Yeah.
And this angle is B, no?
Yeah.
Correct. So all we need to do is show that this angle is 180 minus A.
Yeah.
KNC, right?
Yeah.
So we know that this angle is this, right?
Yeah.
Correct.
Yeah.
And can we find out this angle now, right?
Yeah.
So
Right.
let's try to find out that angle. If we find that, then we are done, right?
Yeah.
So basically, I have to show that angle KNC is equal to 180 minus A. Show, right?
Yeah.
Uh, so KEIC is cyclic. So what is angle?
Yeah. We know KEN is 90 minus half C.
KEN is 90 minus KEN is 90 minus half C. We got that no earlier. Yeah.
So can we show KE?
No, KEN is we got 90 minus A by 2, right?
Yeah.
Right. And oh, okay. And hmm, I'm thinking what. Hmm, okay. First of all, hmm, okay.
KBM is half B.
Which one? K
DM.
B M is
Yeah.
half B. Yeah, that we know.
And then KMB is what, 90 plus C. Plus half C.
This angle.
Yeah. So we know BKM.
Uh, we know this angle because we know this angle is half C. No.
Because like from wait.
Do we know this top angle here?
But we know CNM. CNM is a isosceles triangle.
CNM. Which one is isosceles?
CNM.
CNM is isosceles, right?
Because NNM. Wait. Not NNM. Sorry. Wait, I saw wrongly. N and M are midpoints, right?
But that doesn't mean it's isosceles.
Oh, so CDE, that's isosceles, right?
CDE.
Oh, yeah.
I don't think it is correct. No, what you're saying.
Yeah, I was wrong.
Yeah. 1 second. Let's think. Wait, we have a 90-degree triangle. No, let's use that. Okay. Oh, again, same thing, dude. Look at the triangle. Because of part one, we have this, right? CKB,
Yeah.
right?
Yeah.
And M is midpoint here, right?
Yeah.
So now we know that MK is equal to MC, right?
Oh, yeah.
Right?
Yeah.
Now you can say CKM is isosceles, right?
Oh, yeah.
Correct.
Oh, yeah.
So if this angle is B, we know this angle and this angle now, right?
Yeah. Oh, so we know that everything.
So we know this top angle now, right? Which we wanted to find, right?
Yeah.
This top angle becomes 90 minus B by 2, right?
Yeah. Wait.
Then only it will add up, right?
Yeah.
This top angle is 90 minus B by 2. And we know this angle is this much, right?
Yeah.
So adding these two, we get 180 minus B minus C, right? Which is
Yeah.
A, right?
Yeah.
So this must be 180 minus A. Basically, I'm saying adding this angle and this angle, right? You
Yeah.
get this, right?
Yeah.
Which adds up to A, right?
Yeah.
So this must be 180 minus A.
Oh, and from exterior angle.
And then you can just say that this angle is A already by parallel lines and all, right? Midpoint theorem.
Oh, yeah.
So this plus 180 minus A means 180. So this is a straight line.
Yeah.
You understood?
Yeah.
So see, actually in last two problems, we are using the same thing, that right angle triangle midpoint of one side, right,
Yeah.
is circumcenter of the right angle triangle. Midpoint of the hypotenuse is circumcenter.
Yeah.
And here the earlier part was about finding all the angles to prove cyclic, right?
Yeah.
So mostly actually, if you see, most of the problems in this chapter are being solved by like angles and basic theories, right? Angle chasing.
Yeah.
Then which one was there a problem? Which one was a problem?
What problem?
After this, you haven't tried.
Oh, yeah. I haven't tried the last several
Okay, so
4950 and 51.
yeah, so you can try that, and we can actually focus on next week's class can be about circles. Okay. So chapter 2, right?
Yeah.
So chapter 2 theory, and sure, most of the theory you already know, right? I think
Not sure.
some theory you don't know. Okay. So we'll discuss the theory also. Power of a point, you probably know.
I don't know the radical axis or things like that.
So radical axis, radical center we will discuss. And coaxial circles 2.4 you can ignore. Okay. Coaxial circles are not super important. You can ignore 2.4 there. You should read everything except 2.4.
Okay.
And yeah, so I can quickly tell you also, radical axis is not a big deal. Uh, what it says is that like if there are two circles, right?
Yeah.
Suppose you have two circles. Now, can you find a set of points or a locus such that, or set of points such that you can draw equal length tangents to both the circles? Equal length tangents to both the circles. Such points form a straight line actually, and that straight line is called the radical axis. So basically
Okay.
what it means is, okay, I can take a point here from where I can draw a tangent like this having this much length, right? But
Yeah.
from here, if I draw a tangent to this circle, that length is very much bigger, right?
Yeah.
So this is not on the radical axis. However, if you choose a point nicely here, let's say, there might be a point which is such that tangent length here is equal to tangent length here, right?
Yeah.
And there could be many such points, right?
Yeah.
Such points, basically, you can form a line, and that line is called radical axis. Basically, any point on the radical axis is a point such that from there you can draw two tangents of equal length to both the circles, right? Now,
Yeah.
the way it is presented in this book is pure geometry presentation by saying power of a point and all. Power of a point you can read and you will understand. It is not very difficult. Normally, the way you can also understand it is if you write the coordinate geometry equation of a circle, right?
Yeah.
You know about this type of things, right? This.
Yeah.
So if you have two different circle equations, right? I mean, obviously this is wrong because both the circles are centered at the origin. But uh, basically, you have to find locus of points such that they are equidistant from two circles, right?
Yeah.
So in coordinate geometry, you will realize that if there is a point P outside a circle, what is the length of tangent from that to the circle? Do you know this part? No.
Just like use a Pythagoras theorem and then
Correct.
find the.
So do you know that this is also equation of a circle?
Oh yeah, I know.
So this point, you know that it is minus G minus F, right?
Yeah.
Okay. So then you know that distance, or by Pythagoras theorem, you can find out this distance, right?
Yeah.
Because radius of the circle is root over G square plus F square minus C, right?
Yeah.
And this point is minus G minus F, and this location is XY. So you know this distance also, right?
Yeah.
So once you actually find this length, right?
Yeah.
You will realize that it comes out to be PT is equal to basically root of x square plus y square plus 2gx plus 2fy plus c. I should have written it as x1, y1, and then you would just have this. It will come out to be this. Okay. What does it mean? Basically, you'll put the point in the circle equation, and whatever expression comes out, right?
Yeah.
Square root of that is the length.
Okay.
Like you can check it out. Like let's check it out for a simple situation. So let's make a simple circle equation. Okay. So circle is centered at 1, 1 and radius is 2, let's say, right?
Yeah.
X minus 1 whole square plus y minus 1 whole square is equal to 4, right?
Yeah.
And the equation of the circle will be x square plus y square minus 2x minus 2y plus 2 minus 4. So minus 2, right?
Yeah.
This is the circle equation. And
This is 1, 1.
1, 1,
And
radius
radius
is
2.
2. And let's choose the point somewhere here, 3, 2, right?
Yeah.
3, 2 is outside the circle, right?
Yeah.
3, 2, the distance is 2, 4, 4 plus 1,
root 5.
that is more than 2. Yeah,
Yeah.
correct. So it is outside the circle, right?
Yeah.
So then tangent is possible. So what I am saying is, you can find your length of tangent by normal method, right?
Yeah.
This distance is basically root 5.
And
This is 2.
that, oh, that's 1.
And this is 2, right? And
Yeah.
so this should be basically
1.
1, right?
Yeah.
Correct. And now what we will do is we will check whether what I said is correct or not, right?
Yeah.
What I said was, take the point, put it in the circle, and whatever you get, root of that, right? So 9 plus 4 minus 6
6.
minus 4 minus 2, right?
Yeah.
So you're getting
Oh.
1, right?
Yeah.
You understand?
Yeah.
So basically, from an external point x1, y1 to a circle x square plus y square plus 2gx plus 2fy plus c is equal to 0. The length of tangent is basically root of, you put that point in the circle, right?
Yeah.
Okay. Correct.
Yeah.
So actually, this is just a coordinate geometry way of talking about power of a point. So square of this length is called power of a point. Okay. So power of a point P, this point P. What is the power of this point P? That power of this point P is equal to length of tangent square, PT square, right?
Okay.
And that is actually whatever you get when you put the point P into the circle equation.
Okay.
Right? Now, imagine what would have happened if the point P was lying on the circle, right?
So it's 0.
0, right? So that means the tangent length is 0, which makes sense. If the point is on the circle itself, what is the length of tangent you can draw to that point? It is 0 length, right?
Yeah.
And if the point was inside, the answer here would have come out to be negative. So square root would not make any sense because no tangent is possible, right?
Yeah.
So that is the whole theory. Now, why am I telling you all this? The reason I'm telling you all this is, now if you have two circles, right? Correct.
Yeah.
So now to find the radical axis, like let's say this circle was like this, 2gx1 plus 2f. Okay, I'm making a mistake. I'm saying 2g1x plus 2f1y plus c1 is equal to 0, right?
Yeah.
And let's say this circle was x square plus y square plus 2g2x plus 2f2y plus c2 is equal to 0, right?
Yeah.
Now, I need to find the set of points from where equal length tangents can be drawn, right?
Yeah.
So what will be that set of points? Let's call it x comma y, this point, right? One point like that is x comma y, right?
Yeah.
Length of tangent from here to this circle, we know, is root of putting xy in this equation, right?
Yeah.
So that will be the same thing as this, right?
Yeah.
I'll just write it like this. Let's say the length comes out to be this. And that should be equal to the length here, which should be this, right? Root of that.
Yeah.
So you will get this 2f2y plus c. And then you square it. Once you square it and cancel stuff, you will realize that x square, y square gets cancelled, right?
Yeah.
And you end up with this 2g1 minus 2g2 x plus 2f1 minus 2f2 y plus c1 minus c2 is equal to 0, right?
So it's a straight line.
This is a straight line. And this straight line is called radical axis. Okay. So this straight line is basically telling you the set of points such that equal length tangents can be drawn to both the circles. Right?
Yeah.
And if you notice, there will be some nice set of properties you can see here. So if this straight line is like this, what is the slope of this straight line? Slope of this straight line is negative of coefficient of x by coefficient of y, right?
Yeah.
So minus 2 g1 minus g2 by 2 f1 minus f2, right?
Yeah.
So slope of this line is g2 minus g1 by f1 minus f2, right?
Yeah.
And now check one thing. The circle center here was minus g1 minus f1, right?
Yeah.
And here it was minus g2 minus f2, right?
Yeah.
If you join the circle centers, right,
Yeah.
you get another line, and that line slope, if you check out, it will be slope between these 2 points will be minus f2 plus f1 by minus g2 plus g1, right?
Yeah.
So you will find that this and this, these two slopes are perpendicular. Like if you multiply, you will
Oh,
see
it's
g1
one.
minus g2 here. That will cancel with this with a minus 1. And
Yeah.
f1 minus f2 will cancel without a minus 1, right?
Yeah.
So one important thing to realize is that radical axis is always perpendicular to the line joining the centers, right?
Yeah.
To the line joining the centers. So to find the radical axis, what you should always try to see is join the centers, and it will be somewhere in the middle and perpendicular, right, to that line.
Yeah. Yeah.
After that, it's about what is the size of the circles to decide how far it will be from each, right? Because then only the PA and PB should be same, right?
Yeah.
So equation of the radical axis also you can understand this property that it will be perpendicular to the line joining the centers also.
Yeah.
However, now when you read this, it should be more easy to figure out what is happening here. And what is radical center? Now, basically, he's just extending the idea. So if you take 3 circles, right?
Yeah.
Correct. So now for these 2 circles, you can have some radical axis, right?
Yeah.
And for these 2, you will have some radical axis, right?
Yeah.
And for these 2 also, you should have some radical axis. It turns out that the 3 will intersect. Okay.
Yeah.
Basically, if you take 2 at a time, right, you will get
Also.
one radical axis for each of them. And it turns out that those 3 radical axes intersect at a point. That point is called radical center.
Okay.
Basically, from that point, you can draw equal tangents to all 3 circles, right?
Yeah.
That is the radical center. So not very complicated, but the way that I have told you right now is coordinate geometry based. And what Ivan Chen will tell you here is pure geometry stuff.
Okay.
Okay. So you should be able to understand it now. So just read through the parts here. If you have any difficulties, we'll discuss it anyway.
Okay.
Ignore the coaxial circles part.
Okay.
So what we want to do is finish the circles chapter in the next week and try the exercises there also. So you should try the last 3 questions of your previous chapter and read circles chapter and try exercises in the next coming week. Okay. We'll do all that in the next class. Okay.
Bye.
That's all for now then. I'll see you next time. Bye.